Hi guys, today we are going to design a circuit. Oh, that circuit will generate electricity. Is nothing than solar power generation, which is widely used in commercial and domestic purposes in our houses. Okay, now we are going to design that in MATLAB. Okay, after opening MATLAB, open Simulink and then open this page. And now we are going to move to library browser so that we are able to access the library in this Simulink. And one more thing is this is 2023 version. So now in this Simlink in Simscape in electrical, go to specialized power systems, power sources. There you got power GUI, continuous block. This is the basic block to run our circuit, right? Okay, add block this to the model. And now we want solar panels, right? In this PV array is there in specialized power system sources. Click on that and add block this. And after that go to Simlink and in commonly used blocks get constraint, so that by this constraint we will give the sunrise and temperature. Okay, and take one scope so that we can observe the AC waveforms. And again in specialized power systems in passives you will get a series RLC branch. Okay, take one branch and go to power electronics. There you got diode and IGBT diode also, and take one universal bridge so that universal bridge will convert DC to AC, right? Our house need AC voltage but not DC, so we use this universal bridge. Okay, and now go to power electronics. In power electrical control, take one PWM generator so that we will give this PWM generator to this universal bridge. And we take pulse generator also. For that go to Simlink and in sources you will get pulse generator, add this block also. Okay, now everything is fine, but we have to measure the how much voltage, right? So we have to take voltage measurement block also. Yeah, these components are fine. Now go to this and separate all the components one by one. Now after separation connect one by one, but I have said that constraint by constraint we can give the sunrise and temperature, right? So here I have connected those two to the temperature and irradiations. See, I will zoom it, that irradiation, and below one is temperature, right? So we have to give the values also. For irradiation give 1500. It's not time, we are giving that in frequency. Okay, irradiation, that waveforms. Okay, and temperature 25 degrees Celsius. Yeah, here one important point is from the solar panels we will get 100 to 150 range constant DC voltage, but for our house we need 240 volts, right? So we have to boost the input, that output voltage of the solar panel. So we have to connect a boost circuit. So the boost circuit is having one capacitor and inductor and IGBT diode. So I will connect later. So in this series RLC branch, take this as C capacitance, and its value is 0.006 Faraday. Okay, after converting it to capacitor, connect like this, positive to positive, negative, and then we have to connect one inductor, right? So take that capacitor, copy paste, and make this as L, and that value is to 0.02. It's enough. Yeah, connect that inductor to like this, and connect one diode, and also connect IGBT diode in parallel to this circuit. Okay, now this whole circuit acts as a boost converter. Yeah, I have connected it. Now the output of this boost converter is also a DC current. So we have to convert that DC current into AC. Okay, so this for this we have to use one universal bridge. See here, that universal bridge has left side three terminals. That three terminals indicates the three phase transformer, but we need that three terminals to right side, right? So just control I to flip the block, and now we just want a two phase, two terminal two phase transformer, not a three phase. So just make it to two number of bridge jumps, and make that power electronic divides to IGBT per diode. We are giving IGBT diode as a boost converter, right? So we have to give the input to the same to the universal bridge. Now make connections to it. Yeah, now the output of this universal bridge is AC current. So we have to give that AC current to some load, right? So we have to connect one resistor. Resistor acts as a load. Resistor itself acts as a load, right? So we have to connect that resistor at the output of the universal bridge. Yeah, I have connected. Or give this resistance value to 1 ohm or 10 ohm, whatever you want. And now connect the PWM generator 2 level to the universal bridge. And before connecting, we have to change the PWM generator type to three phase to single phase 4 pulses, and select internal generation of a reference signal. Yeah, now click on OK, and then give the connections to the universal bridge. Now we have to measure the output voltage, right? So connect the voltage measurement in parallel to the resistor. After connecting, connect the scope also to observe the waveforms of the output voltage, and the remaining one is this pulse generator, right? Give the connections of this pulse generator to the IGBT diode. Yeah, after this connection, how much period of time we have to given first? 1 by 1500, right? So change this period seconds to 1500, that is 1 by 1500. Now here our circuit is ready, but I want to observe the output voltage from the solar panel as well as the output voltage after the boost converter. So what we have to do is I have to connect the voltage measurement across this output of the solar panel and also the output of the what is that, boost converter. Okay, yeah, I have connected everything. We have to change the PV array values also. Okay, we have to give that parallel strings to 20 and that series connected modules to 5. Okay, now run the circuit. uh, Yeah, after running the circuit, you will get the waveform like this, a constant DC waveform in the first scope, and this is the waveform we obtain at the last scope. It's like AC waveform, but we doesn't obtain the pure AC form. So to get the pure AC, we have to connect a LC filter so that we can obtain a AC waveform. Okay, yeah. What we have to do for LC filter? LC means one inductor and capacitor, right? So I connected one inductor. Now the capacitor is always connected in parallel, right? So get the copy paste, simply get C and the value is 0.006 and connect it parallel to the circuit. Yeah, after giving connections, once run the circuit, and we can observe the pure AC form in the scope. Okay, yeah, see here. Don't worry about it. If you zoom if you zoom it, we will observe the AC waveform. See that that is an AC cycle. I will clearly show you. Just click zoom and drag. See, this is the pure AC form which we are getting in the house, right? Okay, I hope you understand everything in this session. Okay, until then, bye bye.